Hi, welcome to Narcolepsy Pumpkin. In the last episode, we touched on moving everything to do with the state into one place and making the functions act upon that state, return a new state. We started a journey on getting rid of the arrays which are still mutable. In this episode, we are going to continue that journey into making the array, that two-dimensional array for the maze, into an IEnumerable of IEnumerables.
As a preemptive move, I'm going to pop all the functions that I think I'm going to need to edit down to the bottom, the same as I did with the previous, to effectively change them from being functions within the function that are acting on those internal variables into functions that are in the class. And then I'm going down each of those functions and making it return a new iMaze state, making sure that it's static and resolving some of the errors that exist that are easy to solve at this point. This is a point where we're going to take the plunge and change our interface for the state.
Because I've decided to go with an IEnumerable of IEnumerable in place of that two-dimensional array, means there is a lot of things to fix. Everything that touched that two-dimensional array now does not work. So we need to go through and address all that before we move on any further.
So the first thing we've got to do is create a new function to construct an empty maze structure. So while you're watching that, in the immortal words of Richard Brunning from Bad Obsession Motorsport, I'm going to put the kettle on and get the funk out. Now we've sorted out a new way of creating a blank maze, we can get rid of the old one. We now have to sort out that first row of the maze. We can't just punch a hole in it like we did before. We now have to create a new structure based on the existing IEnumerable of IEnumerables. That structure takes the form of what is effectively an IEnumerable of rows. So what we have to do is discard the existing row 1 and replace it with a version where we've taken the element we want to replace out and put in a new element that is effectively the opening, that initial doorway into the maze. We then have to construct that back into the full IEnumerable of rows so we can put that structure back into a new version of that maze state.
What we need to do here is actually make a function that returns a two-dimensional array based on that IEnumerable of IEnumerables we're now using internally. You can't take an IEnumerable of IEnumerable and just say toArray, because that will just give you an array of IEnumerables. So we do have to do a little bit more work here to translate our current state into the output that we've already contracted in to our interface. The aim is basically to get something that's quick and dirty and working initially, and then we're going to make that slightly better by refactoring it into something that uses link. That should give us a fairly small function that does exactly what we need.
In order to illustrate this in full, what I'm doing is writing this piece of code out in what is effectively longhand by having the for each loop, each of the variables and elements of it described separately. Then the refactor of this is then to condense that down into the link equivalents of those longhand pieces of code. this should give us a fairly concise function that is still relatively easy to read.
Because we've moved away from that two-dimensional array, and that an IEnumerable of an IEnumerable is now immutable, we also need to address all the functions that were changing the internal state of that maze array directly. Those now need to be transitioned to do the same thing as the functions we did in the last episode, where they return a new state rather than affecting the current state.
As with the previous example, I'm writing this out in longhand. This makes it a little bit easier to see what's going on and helps with some of the refactoring, which is the next step. You'll notice that a lot of this is likely to be reusable because the things we're doing in this particular function are very similar to all the others, in that we're editing a single cell within the maze. So one of the elements is going to be changed at a particular set of coordinates. Therefore, there's definitely going to be some reuse. So now we've got that function in place, we can now refactor it down into some more concise functions and make it a little bit more readable and a little bit more reusable. At the moment the function here is based on the state, but to make that reusable we're going to have to make it so we can pass in explicit parameters for the cell we want to change in effect. So the easiest way to do that is to use the refactoring capabilities that exist in ReSharper to push those state variables back out as parameters. That gives us a function we can now reuse, because we can pass in a different set of parameters for each of the different functions where we want to effectively change the cell that's above or below or to the side. Now we've already got a function that opens the top, we need a replica of that to open the side. So that's pretty much a copy, and it's an intentional duplication. We can probably refactor some of that out later, but for the time being, that should get the job done. So now we can shuffle out some of these local functions back into private functions within the class. The reason for this will become more obvious later, but it's essentially to make refactoring and separating these functions out much easier.
The last two parts of this puzzle, in sorting out all the things we've broken by changing that two-dimensional array, are the display, the functions that are actually writing that out to the console, and the tests. We've literally broken all of the tests in doing this. So we need to go back and work out why those tests are broken. And it's actually because I've chosen to make the IEnumerable logically readable to a human rather than something that mimicked the original structure inside a two-dimensional array. So what we're actually going to have to do is kind of move the numbers around so those grids match up with what we've actually got.
So logically, what we're actually doing here isn't actually a lot different. We're iterating currently round an inner and an outer segment with two variables. What we're actually going to do in a new one is iterate round the outer IEnumerable of rows and then the inner row to get each element out. There are little nuances here and there, but essentially the format is pretty much the same. So, what I thought was actually going to be a relatively quick and easy fix to all the tests turned out to be a long and arduous journey, demonstrating the risks of making large quantities of change when refactoring all at once. The fact that the tests exist was a comfort, but it was hard work to find the error I had actually made. All this pain and anguish turned out to be caused by a simple typo, where I'd stupidly used take instead of skip. Once I'd found this and corrected it, I could continue with the original task of sorting out the tests based on those grids of numbers that those characterization tests are wholly based upon. Or, so I thought. It turns out I'd made another faux pas in the createEmptyMaze function, where I'd actually created a bit of a reference hell by creating a single empty row and reusing it. The easiest thing to do to fix this was to create a function that created an empty row that I could call each time based on the number of rows I needed. This meant that each of the rows was an independent referenced IEnumerable, as opposed to the same reference to the same IEnumerable, meaning that while the reference to the head stayed static, even when changing it, it meant I'd actually affected all the rows as opposed to just one. Some of the other errors I found involved tweaking some of the zero-based logic that was used for the original arrays so that we were actually skipping and taking the right amount of elements. The final fix turned out to be revisiting the first part where I was looking at the initial entry to the maze. After a good night's sleep and a fairly strong cup of coffee, it turned out the logic to this didn't really stand up as it should. Annoyingly, even though I was fairly sure the logic was correct, I still had a failing test. Testing it visually meant it worked, and it turned out to be a typo in the test itself. That brings us to a nice conclusion for this episode. In episode 6, we'll be continuing the journey and starting to split up the code as well as refactor it further. This will start to build out some structure that might make a bit more sense.